Hey, Matthew. Good morning, buddy.
Hey, what's up?
How's your day going?
It's good. What about you?
It's going well. Productive.
That's
Be right
good.
back. I need to turn my light on. Hang on a second. How are your classes going this semester?
They're good. I'm like a bit behind on some work though, I think one project or something. So I have to finish that. But other than that, I'm doing pretty well.
How you feeling in
Been
this class?
in this class, I think I'm just missing the student loans. I didn't get that. So I have to complete that, and that's the only thing I'm missing in this class.
You're talking about section 3, you mean?
Yeah, the section 3 homework.
All right. Well, section 3 and 4 are related. So set a goal today to get section 3 done. We may take 2 days on this. It all depends on how fast we go through this lesson. This may take 1 or 2 days. So if it takes 2 days, get section 3 done tonight and get caught up. And then obviously, keep working in section 4 with me as we work on it today. And then by Thursday, you should be, all up to speed.
Yeah.
Okay. And it doesn't feel good getting behind. So try to get caught up ASAP and you're going to feel much better. The stress is going to be taken off your shoulders and everything. Well, good morning, everybody. How's everybody doing this morning? Getsy, how you doing? You look like you're in a unique situation here.
I'm in my car, or in my parents' car in the garage because my house is an icebox and the garage is the warmest place.
What,
And
your heater doesn't work or something?
Huh?
Your heater doesn't work?
Yeah, and he won't fix it.
Oh man, I'm sorry to hear that.
Yeah, we've been living like this since winter. No heater.
Oh man, well, hang in there. But I'm proud of you for logging in and staying up with me. That's a sign of a good student. So Getsy, good job on that. Okay, very good. I'm proud of you. All right. Well, as we get ready here, everybody, you should have your cameras on first of all. So turn them on. That's not a request. It's part of the deal. And then also get all your resources ready. You're going to need a lot today. So look at my annotations up there at the top of the screen. We're going to be using Desmos graphing calculator today. So get that opened up on a tab. You may also use it on your phone. Some people do their calculations because they have it downloaded on your phone. So that's cool to use there. That's not a problem. So, or iPad or computer, either one. I'm on my computer, so I'm going to have it open up on a tab. You're going to see me use Desmos the entire time. You're going to submit all your Desmos work today. So keep that in mind. I'll talk about that here in a minute after we talk about our quizzes. So you're going to need that. You're going to need extra paper because there's no way you can do all this work on this lesson in your workbook. So get extra graph paper out or whatever paper you have, get that on the side. I would also suggest you get your notes out, your formula page, because there was a formula in section 3 for the monthly payment that you're going to need to recall. If you don't have it memorized, no big deal. That's why I said keep a formula page. And then for those people that watch the video on section 3.4, there was a new formula for the term. We're going to talk about that. So you're going to need to add that to the formula page. So get all those resources ready, pencil, red pen for annotating. And then also, if you have not looked at the annotations on your quiz, do so right now, because I'm going to bring up some student samples and I'm going to give you guys an opportunity to correct your quiz and resubmit for a higher grade. So we're going to start off with that today. For those people that didn't take their quiz, you're going to see me at 1:10 today in intervention. If you don't, then you forfeit your opportunity to make up your quiz, because there's quite a few, well, not quite a few, but there's about 8 people that chose not to take their quiz for some reason. And you can't survive in a course with zeros, okay? Especially in the test category or the quiz category, you just can't make it. So I've been commenting a lot on your student work, your homework that you turn in, as well as your quizzes. I've been giving everybody opportunities to resubmit your homework for better quality and a higher grade. I've been commenting on your quizzes and your annotations, giving annotations because they're free response quizzes. And I've been asking you guys to fix, make corrections, and resubmit. And I've only had a small portion of people do that. You know, when a teacher gives you guys an opportunity to resubmit your work for a higher grade, I would highly suggest that you take that opportunity because not everybody allows that. Okay, so we're going to start with your quizzes here and transition. I'm going to show you some student quizzes. So get out pencil, red pen. You can do your corrections in red as opposed to maybe doing it on a separate sheet of paper. Just write directly on your quiz in red, do your corrections there, and then scan and submit. There's too many people's with your videos off. I'm going to make note of those people that don't. And if I have to call home and talk to parents and figure out what's going on, then I will. There's no reason why you should have your camera off if you're doing the right thing, which is participating. Okay. So let's see here. Oh, Ryan, I got your message. Okay. So talk to your parents and try to get your technology handled ASAP because that's part of the, part of it. So, okay. So let's get started here. Let me show you some quizzes here and let's do some quiz corrections. And you guys, let's start using our mics a little bit here. We get through a lot of material more, faster when you guys participate both in the chat as well as just speaking up. Turn your mic on, speak up, talk to me. Kylie, I got your message. Thank you.
If we don't have it with us, can we just do on a separate paper? Like, is that okay?
No, you can do it anyway. So you can either do the corrections directly on your quiz, Charlize, or you can do it on separate. So totally, whatever's best for you. Okay.
Thank you.
Yeah, and then so let's go through it right now, make some modifications, and then you guys can scan it later today when you have time, and then get it uploaded. And I will obviously take a second look at your quizzes, and if you improve on everything, then I'll be happy to raise your grade. All right. Okay, so there were only a few common.
Mr. Ainsworth, quick question.
Yes, Riley.
So I'm going to intervention today for my period 1, class 2, and that's at 1:10, isn't it?
Yeah, all interventions start 1:10. So what we can do, Riley, if you're busy already doing that, just text me what time, just do it in Remind, private message me in Remind and tell me what time works for you. And I'll meet with you later on, after your intervention's over.
Okay, thank you.
Yeah, that goes for everybody. So I know there's multiple interventions going on and different things going on because you guys have multiple classes. I get that. So you just have to communicate with me effectively. Let me know what you need, what time works, and I'll work around your schedule as best I can. Okay. Okay. Dun, dun, dun. Hang on for one moment here. So I was just checking a message from a student here. So just a second. Kylie, I got your message, but just please let me be a little bit more detailed in your response and just let me know what's going on and then I can understand. Okay. Okay, so quiz time. So here we go. Let me show you a common mistake made in the classes. I have 2 classes, period 1 and 3 are both financial algebra. So when I make comments, I'm making comments over, over about 70 students. Okay, 70 students here. So first of all, in part A, if we look here, first of all, let me just say this because this is important. This is good. Let's highlight this word right here. It's called unsubsidized. Now, unsubsidized means something. Okay, so let's highlight that word and let's write down what it means. If you get a loan out when you go to college and you get a federal loan that's unsubsidized, that tells you or means to you that you have to pay the interest back. That the government or the Department of Education is not going to pay the interest that is accruing during the 4.5 years that you don't have to pay your loan. So circle the word unsubsidized and write down interest must be paid back. Okay, interest accrued during the 4.5 years. So accrued means, you know, it starts building up. So interest accrued during the 4.5 years, when I say 4.5, because typically people go to college for 4 years, but you get that grace period of 6 months because it takes time to find a job. All right, so they give you a 4.5-year grace period. It's called a deferment. You don't have to pay interest during that time, but interest still accrues, and interest accrued during that time, during the 4.5 years, all right, must be paid back. Must be paid back. You're going to see why that's important right now. That's what unsubsidized means. If it was subsidized, that means that you do not have to pay it back. And that's a harder loan to get. There are some serious qualifications for that one. Okay, so that's first thing. So having said that, most people got part A correct. The entire class, almost the entire class got that part right. So getting the interest by using your principal rate times time was pretty simple. All right, you take that interest, okay, you add it to your principal, okay, principal plus interest. All right, principal plus interest gives you the total balance. Most people got that right too. But here's the deal right here. This is where the mistake was made by the majority of you, and the majority that made this mistake have to fix it. And this is the key point. Because it's unsubsidized, you have to pay the $8,900 back plus the interest that you accrued during the first 4.5 years, which means you got to take this number here, $10,217.65. Okay, so let me highlight this right here. This number in green. You got to take that and substitute it down here in your monthly payment formula, which this student didn't. But what the good thing is that this student right here did a good job overall. And the method is good throughout this quiz. This person actually knew a lot. And this person actually did a great job. But all you have to do, if this is you, that's one of you guys in here, is take $10,217.65, substitute it into your monthly payment formula. All right, recalculate it, get a new monthly payment. Now, everybody look at the screen. If this is you, you just get a new monthly payment using Desmos. You take that number and multiply by 120. So method is good there. Method is good. Okay, you get a new total. This is called the total paid. All right, and then you take that number and you subtract the original loan. This is the loan amount. Okay, and you get the total interest paid. Keyword total interest. Okay, and that's how it was done. So that was the most common mistake, and I told everybody. Thank you, Elijah. And Joshua. I made comments on your quiz by hand, but I also typed out, and I said, hey, make corrections and resubmit. And I've only had 4 people out of 70 do that. And I'm not sure why you guys aren't correcting your quiz and resubmitting. Maybe you guys can enlighten me right now why that is. Because when a teacher gives you an opportunity to correct and resubmit for a higher grade, I suggest you do it. Can anybody let me know why you didn't do it yesterday? Because I have 70 students and only 4 people resubmitted their quizzes. Because I sent a message out to everybody because I graded all the quizzes. Can you guys let me know what was going on in your thinking? Okay, so some of you guys didn't get my message. You guys have got to look when you get a notification from Canvas that your instructor grades something, you should read their annotations. Secondly, and then some of you guys are telling me that you're planning on doing it today. That's fine too. Okay, just get it done today. Make it a point. All right, let me show you a few others. There's a couple other things that happen. So let me show you these. So just keep your eyes on the screen. This is another quiz from period 3, as you can see. Now, this student here did an exceptional job. This student got part A correct, B correct, C correct. The rounding was off a little bit, so you can fix that. You got to round properly, because even 1 penny off will make a big difference in the end. Everybody get your eyes on here. Okay, pay attention here. So you got to round correctly. So that makes a huge difference. 1 penny off can affect the overall by many, many dollars. Okay, so round correctly there. And then here we go, right here. Now, in the previous example, I showed you that we take the total and we subtract the original loan amount, which was $8,900. This student subtracted what was the balance and the interest in the 4.5 years. So this right here, this number here that they found, the 1785.95, was for the 10-year period only. The interest accrued during the 10-year period, not including the 4.5. So this person has to take the interest in part A, which was during the 4.5-year period, add that in to get the total, and you will get the correct number there. Or they can simply subtract 8,900 and get the same answer. Give me a thumbs up or down on the screen, indicating that you either understood that or not. Understood, not understood. Give me an indication. There's 2 ways to calculate the total interest. Okay, I'm saying 2 different ways. This student only has to do a minor correction, and then no matter what grade, this student got a 90, I'll raise it to a 95. Okay, so what I want, my main goal here for you guys is to learn from your mistakes so you don't repeat them. Are you guys understanding that here? We need to learn from our mistakes, because if I don't tell you what's going on, then you're going to keep on repeating it, and that's not good. Okay, you guys got to get better and better and better. That's part of the learning process. Sorry about that. So this person, did the same thing. So this person, excellent job throughout, got the interest for the 10-year period in the last part. That's the interest for the 10-year period only. So I equals, this is for the 10-year period only. So this student needs to add in part A interest as well. So this represents the interest for 10-year period only. But I asked the total. So you have to just simply add in the interest during the first 4.5 years and you're good to go. That student did really well. This is the correct solution. Okay, and we're good to go. Okay. Okay, so before we transition here to the main lesson here, any questions in respect to your quizzes? Let me address that now for everybody. Okay, then let's get started. Okay, so we're going to be doing using the Desmos graphing calculator instead of the scientific calculator, because believe it or not, they can do the same thing. So let me minimize this so I can show my screen. And what I want to do is everybody launch this right here, Desmos graphing. And I've suggested that you guys sign in and get an account. So I'm going to go over this again because I have a few new people in here. So if you look up here on the screen, look in the upper right, I'm already signed in under my name because I have an account. If you have not done so, you could do it right now very quickly. You just enter your email address and get an account. And the reason why you need that is because as we use this, which we're going to use this all day today and all day Thursday, you could save your work because we may not finish the lesson. Yes, Michael, I will later. I will probably not finish the entire lesson today because there's a lot involved. And so if you save your work, we can open that work back up on Thursday. And then from there, you can print off all your work and then include that with your workbook pages. Like right here, if I go to the upper left-hand corner and hit this sign here, I have all the work I've done for all my classes over the years. It's all here. So all I have to do is pull it up. Some of you guys don't even look like you're looking at the computer. You guys look at the computer screen here. I'm trying to help you guys out. So you need to be logged in. Okay, and the very first thing you do is you give your document a title. So give me an indication right now on the screen. Who's already got an account in Desmos? That's only like 3 or 4 people. You guys should be doing it right now so you can do this. For the people that are signed in, let's do this. Okay, click on Untitled Graph. And we're in section 3.4, so let's give it a name, 3-4. And it's called Loan Calculations and Regression. So you put in the title, Loan Calculations and regressions. And what's cool about this, as you save your work, and at the end of the chapter, you can pull up your work again and see how you did it, because there's something called reviewing, which is nice. You got to have good resources. And so now what we do is, as we build our functions in Desmos here, we can save our work as we go, and then we could pull it up later on Thursday and continue working on it. And we could also print it and submit it when we're done on Thursday, because you're going to have to submit all your Desmos work. All right, Desmos, no TI-84 today. I want Desmos only, because I want you guys to learn how to use it. All right, so here we go. So I've got the lesson on the left. You're also going to need some extra paper, because there's not enough room here to do all your setups. So get some graph paper and some extra paper on the side. Give it 3-4 as a title, and you're going to have to submit this too as well. There's just no way you can fit all this stuff in these little spots. Okay, so when you're ready to begin the lesson here, type in ready. Who's ready? Got all your resources ready. You got your Desmos ready. You got your paper ready. You got your documents. You got your workbook. You got you got a lot of stuff today, guys. Okay. All right, so here we go. And then, as we do this, there's a lot to do today. If you have questions, you just turn on that mic and just speak up as we go. All right, so this section relates back to 3.3. So if you have your formula page that we developed in the last section on 3.3 with the monthly payment formula, put it on your desktop. If you don't have it memorized, you're going to need it. Because in number 1, here we go. What is the monthly payment? So you're going to need the monthly payment formula. And like I said, if you don't have that memorized, then, obviously you're going to need it. Hang on for a second, I'm just getting a resource here. Okay, so here we go. So it's number 1. Oh, by the way, I'm not going to do all of these. In fact, I'm not going to do number 1 either. I'm going to do number 2, 3 with you. Let's just circle the ones I'm going to do. So this means in class, and the rest you guys are going to do on your own. Okay. So number 1's on your own. Number 2, 1 and 2 are similar. So if we review number 2, you're going to be good on number 1. So don't worry about that. Number 3 is new. So we have to do that together. That's your new term formula. So we're going to have to develop number 3. That's the new one. We'll do number 4 because 2 and 4 are related. These are similar. But I want to talk about what to do in Desmos. There's a cool thing that you could do to speed up your work in Desmos. So I want to do number 2 and 4. We'll do those first, actually, and then go to number 3. And then new ones are 7 through 10. So we have to do those. That deals with what's called a yearly payment schedule. That's new. So we'll do that together. And then on the next page, you're responsible for number 11 on your own. And then this might be Thursday. It depends on how much we get through, but I'll work through number 12 because that deals with a formula. And this is all new right here, 13 on. That's linear, quadratic, and cubic regression using Desmos. And so this is Desmos required here. If we don't do this today, then we'll do it on Thursday. We'll just go with the flow on that. Okay, so that's the plan. And then you guys are responsible for everything else. All right, so having said that, let's start on number 2. So we're going to go number 2 and then number 4 and then to the new part on number 3. All right, so Max is taking out a 5.1% loan. So here we go again. So let's annotate. So R is 5.1% or 0.051. That's your interest rate or your APR. Okay, he wants to purchase a $17,000 car, and that's your principal in your loan. So P is equal to 17,000. Okay, that's a modest car. The length of the loan is 5 years. So there's your length of the loan. So T is equal to 5 years. And you're going to need to convert that to months because that's always the exponent. So can you guys tell me how many months are in 5 years? Let's start there. Okay, I like that. Okay, 12 months per year, 12 times 5 is 60 months. So T, this is not equal to T. T is 5, okay, but it's equivalent to 60 months. The question is what will the interest be? Okay, so let's highlight that. The question is, what is the interest? Keyword interest. All right, and that is a 3-step process. So I equals question mark, you know, I equals what? Okay, and it takes 3 steps. And this is what we talked about in section 3, in our last section. All right, so let's go off to the side and let's step it out. So to calculate the interest, there's always 3 steps. So what's step number 1 that you guys, that we went through last section? What do we need to know to calculate the cost of the loan or the interest? What's the very first step? The monthly payment. Very good, Kylie. Okay, so we got to calculate the monthly payment. So here we go. Now, again, if you don't have the monthly payment formula memorized, look at your notes in section 3 and get that formula page on your desktop side by side. Pull from it. I don't expect you guys to remember everything. I expect you guys to use your resources. Okay, so the monthly payment formula goes like principal, which in this case, let me see, he wants a $17,000 car. So we start off with that. So $17,000 times R divided by N, which the interest rate in our case is 0.051. So 0.051, divide that by 12 times 1 plus 0.051 divided by 12 raised to the number of compounding periods. Okay, it's N times T. This is N times T right here, and that's going to be 12 times 5 or 60. So this is going to be to the 60th power. Remember, there are 60 months in the 5-year loan. All right, divided by 1 plus R divided by T, so 0.051 divided by 12, raised to the 60th power again, and then minus what? You guys tell me. What do we subtract in the denominator? Use your fingers on the screen. Give me a quick response here. What do we subtract? Some of you guys are responding. Yeah, we got to subtract 1. You got to know. So this again, this is section 3 now. This is section 3.3. Okay, so let's do that. Now we could use the scientific calculator, or we can use the believe it or not, this does the same thing. In the last section, I use this. All right, but the Desmos graphing calculator is going to be used in the last part of our lesson. So what I thought today was we are going to use this entirely, and we're going to save our work so that when we come back together on Thursday, we're going to pull this back up, and we're just going to print it off here and use everything here. Because the graphing calculator can do everything that the scientific calculator can. So here we go, let's enter it in. So let me see here, I got to minimize it here. So let's actually, let me make it a little bit bigger here. All right, so we got to enter in 17,000. So here we go. So 17,000. Okay, times the quantity. Just do what we always do here. Times 0.051. All right, divided by 12. This is the same calculator that I used before. It's just in the graphing version of it. All right, times the quantity. So use your parentheses. 1 plus 0.051 divided by 12 again. You got to close it off before you raise it to the 60th power. Now, before you hit the division button, you got to get out of the exponent. So go right arrow and then hit the division, and then you'll see it change to a fraction, which is what you want. And then you got to divide it by 1 plus 0.051 divided by 12 again, raised to the 60th power, and then get out of the exponent before you subtract 1. Okay, and you're getting this number here. Now, I can't enlarge this and make it any bigger here. So that right there is the monthly payment, $321.59. Okay, so let's record that. So this is $329.51. There's your monthly payment. That's step 1. What's step 2? What do we calculate? What does that represent, Christian? I agree with that, and so does Mia, but what does that represent?
That represents the amount paid in interest.
Not in interest, no. That's what we're going to get later on. There we go. It represents the total amount paid. So if you're paying $321.59 every month for 60 months, when you multiply it by 60, you get the total paid. Okay, so the total paid is equal to $329.51 times 60, which, let's go ahead and get a number there, guys. What are you getting? Put it in the chat, please. Everybody participate here. The better you participate, the better you're going to be. Now, what's the total amount? I'm not to the interest yet. So go back a step there. There we go, 19,000. So let me go to Desmos and work that out. So you're going to take $321.59, and you're going to multiply it times 60. This number will give you the total paid. So $19,295.40. Now, step 3. Let me go back here. So we know the total now. This is the total paid, $19,295.40. How do you calculate the interest, the total interest? Which is what we want in this problem here. There we go, Mia. All right, so we subtract the principal. So it's the total paid minus the principal, which in this case happens to be $19,295.40 minus the $17,000. So we need a number there. So go back to Desmos and then you just type it in. You can even copy and paste numbers here. Like if I, with my mouse right here, if I go and grab this number here, I can highlight it, and on your keyboard, you Control C. I'm pretty sure you guys can cut and paste here. Paste it in here if you want. Yeah, you can if you want, although I wouldn't do that. Okay, I would just type it in. So 19,295.4 and then minus 17,000, just type it in and you get the total interest. And then you can screenshot this if you want, if you're all digital, and you can bring it into your lesson. Okay, and so right here, there it is. So we've got the monthly payment here, we got the total paid here, and then you've got the interest here overall, which is $2,295.40. It's always 3 steps, my friends, always. Who's with me so far? Be honest with me, total understanding here. Jack, are you with me? You guys you got to respond to me here on the screen. I'm watching everybody, I'm looking at everybody. Kyle, where'd you go?
Sorry, I had to use the bathroom.
Okay, no worries. Just come back, get your camera on like everybody's doing. I know a few people like Elijah and Kylie and Ryan, they gave me some messages why the cameras are off. I don't mind once in a while, but in general, you guys keep your cameras on and participate. Students always do better when you participate. Okay, it's just a fact. I've been teaching 29 years, guys, and I've never seen a student really, I mean, rarely do I see a student fully engaged, working their best, and not do well, okay? There's only very few times does that happen. Okay, so we got the answer number 2. Now, number 4, what we're going to do is I want to show you how to use Desmos effectively. Now, 2 and 4 are the same kind of problems. It says, what's the total interest? See right here, whenever they say that, it's the same 3-step process right there. But this time, T is 15 years, okay? 15 years. So how many months is that? You guys calculate how many months in 15 years, because you need to know that. That's going to always be the exponent in our equations. N times T is always the number of years times the number of months. There we go. So 15 times 12 is 180 months. So this is equivalent to 180 months. Make a little note. That's the exponent in all these equations. It always is. Okay, now this time though, watch what happens. We know the interest rate has changed. Hang on, I have to reboot here for a second. There we go. So the interest rates change. So R here, R is 0.0498. So you got to be careful right there. Make sure you make the right decimal. And then the principals change. It's not $12,000 or excuse me, $17,000 like in the previous problem. It now is 40,000. Okay, so how, what would the total interest be on this loan for 15 years? All right, so let's calculate that. So what we do is we go back to Desmos. We don't clear out anything. You go to the next row. Well, actually, you copy the first one here, Control C, and you come down here, the fourth one, you paste it in and you just modify it. This is how you keep record of all your work. And all you have to do is modify the equations, and you can go through your homework and also quizzes and tests a lot faster, which is important too, okay? So let's modify it. We have a $40,000 loan now, so we have to change that one. This is number 4 now. So backspace it, change it to 40,000. You got to change your interest rate in 3 locations. Okay, those decimals, the 0.051 that we used in the last problem is now a new interest rate. It's 0.0498. So backspace and change it. 0.0498 and do that 3 different times. Okay, change all your interest rates in the problem. And again, when you're using Desmos here, you got to change all the correct parts. Everywhere you see an interest rate, you got to change it to the new interest rate. Okay, and there's one more thing that we have to change. And I can't make the screen any bigger. I can't do that on this one here. What else do we have to change right now? What do I need? What's the last thing I need to change in this problem for number 4? What number do I need to change? What to what? There we go. Yeah, the exponent. It's a 15-year loan or 180 months, right? There's 180 months in 15 years. So change the 60 to 180. So get your cursor up there, backspace, change it to 180. And you got to do that twice because there's 2 exponents. Or you can retype all these things in if you want to, but I'm just trying to show you how to expedite your homework, expedite and go faster on quizzes and tests so you get better. And look at your new monthly payment is $315.90. So go down to the next line. Step 2, we got to calculate the total paid. So just calculate it all in Desmos and then bring your work over. All right, so we're going to take $315.90, so 0.90, and you have to multiply it by the number of months. And in this case, it's a 15-year loan. So you have to pay this 180 times. So you got to go times 180. Okay, and that's a big number, $56,862. Okay, and then you got to calculate the interest. So you guys help me out with the next part. What do we do? What's the final step to calculate the total interest over time? Turn your mics on. Talk to me, guys. Come on.
You subtract.
Be specific. Keep going on that.
You subtract. You do 56,862 minus 40,000.
Good job. Thank you. All right. There you go. So let's do it. So good job, Charlize. And so we take 56,862 minus the 40,000. Okay, so minus 40,000. Just type it in. All right, and you get $16,862 interest paid, which is a lot of money. Okay, and so you just take that. I'm just going to screenshot it and bring it over, but you guys just write it down in your workbook here. Okay, and so I'm just going to bring it in. So this is number 4. So the number 4. So again, monthly payment is here. Total paid is here. And then the interest, which is total minus principal, total paid minus principal, that equals this number here, which is called interest or the cost of the loan. It's the cost of the loan. Okay, and that is number 4. Okay, let's pause here. Any questions? We're learning the 3-step procedure to find interest. We're learning a lot of things. We're learning how to calculate the monthly payment, the total paid, the total interest. We're learning how to use Desmos effectively. We talked about how to set up an account in Desmos so you can save your work and bring it in and use it multiple times. Okay. Talk to me, guys. Any questions up to this point? If not, give me some kind of response in the chat or on the screen. I'm looking at you guys right now. Thank you, Charlize, and a few others. Yeah. So thank you, Maddie, Jonathan. How's the speed so far? Is it too slow, too fast, just right? Talk to me here.
Just right.
Okay. All right. So let's go back. Let's do something new. Okay. So it's 2 and 4. We're kind of review. They're based upon section 3. Number 3. Number 3 is a new one. This deals with the, there you go, Elijah. Good. Marissa here in number 3. Again, let's transition here. Wants to borrow $12,000. I'm having a little technical difficulties right now. Hang on for a second. Okay. So in number 3, we want to, she wants to borrow $12,000 for a used boat. I want to do the same thing, by the way. My wife loves going to the river and going out on the water. Who's been to Laughlin, Bullhead City, Needles, Parker, Havasu? Who's been to those places, been on, likes going on the water? Anybody? So Cameron, where do you go?
I've been to Havasu and Parker.
Which one do you like better?
Havasu is more fun.
All right, on near the London Bridge?
Yeah.
Oh, awesome. Okay, does your family have a boat too, or what?
No, we go RV camping.
Oh, okay, cool. We do too. All right, a lot of fun, a lot of fun. All right, after looking at her monthly budget, she realizes that all she can afford to pay is $250 per month. Okay, that's important. Underline that. There's your monthly payment. So far we know she wants a principal. She wants to borrow is $12,000. We know M is equal to $250 in this example, max. Okay, usually people have a maximum monthly payment. I know my wife and I do. When we shop for whatever, whether it's a car, a boat, whatever it is, we have a max because we're not made of money. I'm a teacher and she's a principal. So we have a certain amount of income and that we can afford, you know. So the bank is offering a 6.1% loan. So we know that R is 0.061. It's per month. So N is 12. We also know that. The question is different though in this case. So what's the question here? So the question is, what should the length of the loan be? Here's the question. What should the length of the loan be so that she can keep within her budget? Oh, new question. The length of her loan, that's T. T equals question mark. How many years? So in this case, we have to solve for T, which is called the term, number of years. And so we know the monthly payment formula. So how do you solve for T in that? So here we go. If you have your notes from section 4, you should take them out or just grab another piece of paper right now because we're going to derive your term formula. So, and in the video, Mr. Alex did not do that. So I'm going to dive deeper with you guys. Okay, so I'm going to enlarge this so you guys can see this here. So get a piece of paper out and write down our goal. We're going to solve for T. He didn't do this in the video, so we're going to do this together as a class. I think it's important that you guys know where these formulas come from, and when it's possible to derive it, you know, how do you solve for T here? Which is in the formula here. It's the exponent of your monthly payment formula. You know, how is that done? How do you get from here to here? How in the world does that happen? Because these formulas don't just happen magically, my friends. You're going to submit this too as well. So just put this, get another piece of paper out and write it down. Not the what you see in red. Just put down the monthly payment formula here. I'm going to do the rest with you. Okay, I'm going to show you how to get from the monthly payment formula to the term formula. Term, which is the number of years in the loan. So I'm going to challenge you right now because it involves something that you're familiar with, but I think you need to see it. This is something that's not going to be tested on, so don't panic right now because this is not the easiest thing in the world. So take a deep breath right now. But I want you guys to see it, and so you understand how to go from the monthly payment formula up at the top to the term formula at the below, which are equivalent, by the way. Whether you use the common log base 10 or the natural log base E, as you learned in our last chapter in chapter 2, it doesn't matter which type of log you use. Okay, so here we go. Let's develop this guy, and let's see what happens. All right, so before we do it, tell me to bring it on. We do this in class all the time if we were live in person. Turn on your mics. Tell me to bring it on, Ainsworth.
You bring it on.
Bring
Yeah, that's what I'm talking about. There we go. Thank you, thank you. All right, so the first thing we ought to do is we have to understand something here. We have to solve for t and t's in the exponent. So just before we even get started here, just tell me what you think is going to involve somewhere in the process here. And think back to chapter 2 because we did this a lot. Whenever you solve for a variable in the exponent, what is involved? You guessed it right there. So that will happen throughout the process, okay? But what we have to do, our first main goal is to figure out a way to isolate this expression right here. Just look at my screen. You don't have to highlight everything. Just, we got to figure out how to isolate that expression right there. Because if we get it isolated, all we do is take the log, use a couple log properties, and we're good to go, believe it or not. All right, so the very first thing, what I went through this, because, you know, obviously I have to do everything that you guys do, is I handled the principal first and just massaged a little bit. So what I did is I divided both sides by P. And in the first steps here. So I divided the right side by P, and I divided the left side by P. And what I did is I just shifted that to the left-hand side. And then I'm going to just rewrite it over here. Okay, so I have a little bit more room. So on the left side, I see M divided by P because I divided both sides by P. And on the right side, I still have this crazy fraction here, R divided by 12 times 1 plus R divided by 12 raised to this power of 12t. Make sure your t's look like t's and not pluses. So curve them, okay? And then divided by 1 plus R divided by 12 raised to the 12t power again, and then minus 1. Okay. Now my goal is to isolate this expression up here, which is basically the compound interest formula. Okay, and I need to isolate it. And the first thing I need to do is undo this. I got to clear the fractions. So we're going to do something very familiar. Whenever you clear the fractions in anything you're doing, it doesn't matter what you're doing, you multiply by the denominator. So take out your red pen, and you see this denominator right here? We're going to multiply both sides by it. So here we go. So I'm going to multiply the right side by 1 plus R divided by 12 to the 12t power minus 1. And I'm going to do the same thing to the other side. Now that simplifies things and it clears the fractions. And so on the right-hand side, we're no longer going to have this complicated fraction anymore because the two expressions on the right cancel out. Because as you guys know, anything divided by itself is 1. Okay, so for our next major step, now we have the variable t on both sides of the equation. So we got to handle that too. So the next thing I want to do is I want to distribute through m divided by p into the expression on the left. So let's do that. So I've got m divided by p times this expression, times the first term here, 1 plus r divided by 12 to the 12t power. Just distributing through. And then I got m divided by p times this negative 1. So I got a minus m divided by p. So I just distributed, stop. I just distributed twice, distribute. And the right side is simple. You just bring down the last expression or the ending expression. I'll go slow here just so that you guys can, you know, obviously take good notes, but try to digest this. See if you follow the mathematics here. Now, t is we need to solve for t, and so I've got to get this expression here and this expression here on the same side so I can isolate it. Because it's on both sides. One's on the left, one's on the right. That's not good. So what I want to do is I'm going to shift this term over here on the left, and I'm going to take this term, I'm going to shift it over here on the right by adding the opposite. By adding the opposite. So on the left, I see a minus m over p. So if I add the opposite, it looks like this. And then if I subtract the one on the right, I bring it on the left. So let me see if I subtract, I'm just going to subtract all of this, all of this here, and I got to subtract the whole thing here. So what I get is I get the m over p times 1 plus r over t, or excuse me, r over 12 to the 12t power. And then minus what I subtracted, which is the expression on the right. Let me just put it in the same color here. So minus r divided by 12 times 1 plus r divided by 12 to the 12t power equals just m over p on the right. So all I did right there is just shift terms. I shifted m over p to the right. I brought the right side over to the left by subtracting it. Okay. Just out of curiosity, who's following me so far? Oh, I got a few people. Okay. It takes time. In any mathematical derivation, it takes time to digest. Okay. Now, look right here. Let me highlight something here for you. This is what I need to isolate right here, this term. And it's in common with both terms on the left-hand side. It's in common. It's a common factor. And you guys have learned from Algebra 1, actually, or even, you know, you probably learned in Algebra 1, how to factor out something in common. It's called the Factoring Out the Gcf. So what I want to do is this portion right here, I want to factor out. I want to factor out and isolate it. Okay, so here we go. I'm gonna write it out. I'm gonna start off with that. So I'm gonna write down 1 plus r divided by 12 to the 12t power. I'm gonna put that in yellow just so you can see that I factored it out. And then I'm gonna multiply it by the remaining factors. Now the remaining factors, let me put this in blue so you can see it in another color. So what's remaining is this, and that goes inside the parentheses. So whenever you factor something out, the end terms, whatever's remaining, the terms remaining have to be inside the quantity. So I have to multiply it by m over p minus r divided by 12. I just factored out the common factor right here. That's all I did. Believe it or not, it's all algebra based. You know, these complicated things, they're all algebra based. Okay, so now the question is, what do we do now? Can you guys predict what we need to do since we need to isolate this? You need to isolate the term in yellow. Think simple. Think algebra 1. And don't put it in the chat. It's too complicated. Just turn on your mic and tell me what you're thinking. What do you think we need to do to isolate the term in yellow? Take a shot at it. What do you guys think?
Divide the things in the brackets to the other side.
Exactly. Good job. Let's do that. Let's put it in red. So let's divide by, he said the things in brackets, m over p minus r over 12. M over p divided or minus r over 12. Good job, Matthew. And then these cancel to 1, right? Anything divided by itself is 1. So what do we have remaining? Okay, so let's just bring it down. Here we go. And we're almost done, by the way. So 1 plus r divided by 12 to the 12t power equals all of this stuff here. M over p divided by m over p minus r divided by 12. By the way, if you look at the formula, our goal, hang on, I don't know what the deal is. I'm having technical difficulties here today, so bear with me here. There we go. If you look at our goal, which is this right up here, this is our goal. You could see the same expressions happening here. It's just that we don't have any logs yet. Okay. Having said that, what do you think we ought to do? What's the next major step that you guys learned in chapter 2? How do you solve for the exponent? Think chapter 2 work. Yes. Okay. And so which one do you want to use? The common log base 10, or do you want to use the natural log base E? Which one do you guys want to use? Common log or natural log? Because it doesn't matter. So they both give you the same result. So you guys get to pick. I need someone to step up and say, hey, pick. Okay, there we go, Maddie and Jonathan. Common log, base 10. So we take the log of both sides. So here we go. Log of the left side. So some of this log work is gonna hopefully coming back to your memory right now because we used it in chapter 2. Okay, now our goal, remember our main goal, solve for t. That's our main goal, which is up in the exponent. So now, what do we do? What log property did you guys learn in chapter 2 that we used, oh my God, extensively in the second half of the chapter? What do we do?
You'd move 12t to the front, one equation.
You guys agree or disagree with that? He said shift the 12t to the front. Okay, that's a great idea. So let's do that. Okay, so let's take this 12t. We're using the exponent log property, or yeah, exponent property of log. So shift to front. So you were right on there, Christian. So let's write it as 12t times the log. 1 plus r divided by 12 is equal to this stuff over here. Now, don't write the same thing down. I need to interject here. Okay, we need another log property here. This up here is, this fraction is called a quotient. And I don't know if you guys remember this from algebra 2, so I'm going to help you out here. We need to know how to rewrite the log of a quotient. So let's review from algebra 2. So this is one of the, we need one additional log property. So log base b of, let's say, a divided by c. There's a quotient right there. How do you handle that? Does anybody remember? And if not, I'll tell you, but does anybody remember what to do with a log of a quotient, how to rewrite that? In algebra 2, they called it expanding the logs versus condensing. Does anybody remember how to expand a log of a quotient? Okay, let me help you out. What you do is you change it to the difference of logs. So this is equal to log base b of the numerator, okay, a, minus log base b of the denominator, which is c. You change it from a quotient, all right, to a difference, believe it or not, okay? Log of a quotient is equal to the difference of the two logs. And I know it's been a while, and that's probably why you don't remember it. So let me just help you out there. So here we go. Let's do that. So we have in this fraction, we have a numerator, okay, and we have a denominator. So here we go. So this is going to be equal to the log of the numerator, which is m divided by p minus, again, you always start off with the numerator first, okay, minus the log of the denominator in blue, which is m over p minus r divided by 12. And again, I'm just using properties of logs that you at least went over a little bit in Algebra 2. Okay, we're almost done. We have one last step remaining. One final step. Our goal is to solve for t, and here it is. How do you do it? You guys tell me. You guys should know this. This think simple. Super simple. What do you do to solve for t there? I know it looks complicated, but you gotta challenge.
Divide,
Be more specific.
you divide that whole entire thing right there, that whole entire bad boy. So from like the 12 to the end, you just divide that all on the left side.
And Jonathan agrees with you, and a couple people are smiling like me. Yeah, you divide that all the entire bad boy on the right. That's right. I use the same terminology, Matthew. You get that bad boy and you just start dividing like crazy. So here we go. We're going to divide both sides by the 12 to cancel out the 12. So we do that, and we got to divide and cancel out this log. So we're going to take that entire bad boy on the right and divide it by 12 times the log of 1 plus r divided by 12. And guess what? That's what t is. And that is your term formula. So I'm just going to rewrite it again, just in one single color. This is it. And this is what was stated in the lesson video that you guys watched over the last couple of days. But as I said, Mr. Alex did not derive it for you because he was focusing on application, not derivation. Okay, he did a good job in description and all that in application. He just left out this just because he focused in on application in the video. And again, this is not tested on, so you don't have to freak out right now, okay? But I wanted to challenge you and show you how things develop. We went from the monthly payment formula, which is at the very top of the screen, all the way to the term formula, which stands for the number of years of the loan, which we're going to do right now. We're going to apply it. All right, so this is your term formula. Wow, and that, my friends, is one derivation. Now you know, okay, things just don't magically appear. They actually are derived, through mathematics that you already know from Algebra 1 and Algebra 2. Okay, before we transition to number 3 in your workbook here, any questions on the derivation before we transition?
Can you just stay there for a moment?
I know it's a lot. You want me to zoom in on the second half?
Yeah.
Or do you want the whole thing?
I can also always just go back to the recording. So
It's okay. Go ahead. So as she's recording that, do you guys have any questions on the mathematics through it? Because I'm trying to get you guys to understand, where is this stuff coming from? I'm diving a little bit deeper in the lesson here, obviously.
So those are just steps to get to the formula.
Yeah, this is where the formula comes
Okay.
from. So like I said in the video, Mr. Alex didn't derive it like this. He didn't show all this. The video would have been 20 minutes longer. And he focused on all application examples, Christian, okay? But again, you know, I'm not gonna, this is not gonna be a test question, so you guys don't have to freak out. It's just gonna be application. But I thought it was important that you guys know, because that's the type of teacher I am. You know, I think you guys ought to know. Okay, let's go to the application. Let's go to the actual workbook. Riley, are you good, Tiger? Okay. Let me go back to the workbook here and let's focus in on number 3. Here we go. So now we need Desmos again. We're going to enter this information in. So let me bring up Desmos here. Let's put this side by side. Don't clear out anything. Don't hit the X's. Just go down to the next line because you're going to be saving. Hit the save button right now, by the way. So in case something happens with your computer, which sometimes it does. Now in Thursday, we can pull all this stuff up because we're going to finish this lesson on Thursday. As it looks with the timing right now, there's no way I can finish the lesson. I still have quite a bit more to do with you guys. We'll do that on Thursday. So make sure you save your work here. And if you didn't create an account, then you better screenshot all that stuff and put it in a Word doc. Okay, but I highly suggest that you get a Desmos account. It will benefit you big time. Especially come the end of the chapter when we start reviewing for your chapter exam. Okay, so what am number 3? Here we go. So we got to enter this crazy formula in. So I'm going to do this here. Okay, so number 3. Okay, I'm going to expand it just so you guys can see it better. Okay, so we got to go log. Now hit functions. Hit the word functions. And there's we need to find log. So where is log? Trig. Where's my functions on this thing? So where is it? I usually use the other calculator. Now where's the functions here? I'm looking. Oh, here it is, right here.
Yeah.
It's under miscellaneous. There we go. It's under miscellaneous. So using the Desmos graphing calculator, it's not as fast as the other one, but it still does everything the other one does. So hit log and then type in 250. It's the monthly payment divided by the principal. So just look at your formula now. Look at use your notes on your desktop. Have that crazy formula right next to you because it's not on the screen right at the moment. So 250 divided by the principal, which in this case, in number 3, you want to borrow $12,000 for the boat. So you got to divide it by 12,000. Okay, and then you got to close it off. And then you got to subtract the other log. So go functions, miscellaneous, and type in log. Okay, it's not that hard. And then you type in 250 divided by the principal again, which is your $12,000 loan. Get out of the denominator and subtract R divided by N, which in this case is the interest rate on number 3 is 6.1%, so 0.061 divided by N. N is 12 because this is monthly, okay? So divided by 12, write down N equals 12 somewhere in your notes. It's always 12. Well, you know, just look at your formula, it's always 12. And then close that off. Now watch the screen. I'm going to make a mistake here. Everybody pause right now and look at my Desmos screen and look closely here because I can't make it any bigger. I don't think. Oh, maybe. Oh, I can. Okay. Okay, so there we go. That's bigger. So if right here, if I press divide, look what happens. That's incorrect. Look right there. That's incorrect. I want that whole both logs in the numerator. So if I just press divide, that's going to be incorrect. Boom. So I'm going to backspace and start over. What do you think I need to do to make sure that entire expression is up top in the numerator? What do I need? What symbols do I need around it?
Parentheses.
That's right. So double up on the parentheses. One more on the left. So I'm going to go back to the beginning. Parentheses on the left, 2 on the right. And then when you do that, that entire thing is in parentheses now. Yes, David, put that to the whole entire class. That was a good thought. Okay, so you put that whole thing in parentheses and now type in the rest of the formula. So type in 12 and then go functions, miscellaneous, go to log, and then type in the rest of the formula. So 1 plus 0.061 divided by 12. All right, and give me a thumbs up on the screen if you're getting roughly 4.597. Who got that? I see Mia. Who else? Maddie, Nathan, Tristan, Jack. How you doing on that? Are you using your phone with Desmos, or are you using the computer? The phone? Okay. Like I said, phone, iPad, computer, anything you want. You know, you can, it's a free app, so you could use it anywhere. So that's in years. Okay. And then again, keep all your work and save it. Press the save button, save your work. Now let's go back to the lesson. Let's write down our result. So in number 3, we got our term. T is equal to 4.597 years. Now in the problem, it says round to the nearest year. So what's T equal to the nearest year whole number?
5.
And you got to round up. Okay, now why do you think that is? There's a reason. Why are they saying round it? I'm talking the real reason in reality. When you go to either to a boat manufacturer or you go to the bank and apply for a loan, why do we have to round up in this problem? Why?
Because if you round down, they lose like their money.
Be more specific.
You won't get the exact like amount because it's in T and time is years. So you want to round up.
Let's dive deeper. Let's say if you rounded down to 4, what would happen to the monthly payment? Would it go up or would it go down? Use your fingers.
It will go up.
So the shorter the loan is, the higher the monthly payment, Matthew?
Yeah.
That's actually correct. That's one reason. And she said the max that she can afford is $250 per month. But why in reality, why in the bank is T equal to 4.597 not acceptable? Why do you think? You may not have experience here, so I'm asking you to guess.
At
Guess.
4 years, you're not going to have enough as you would at 5 years.
True, but why would 4.59 not be acceptable in a banking situation, Mia?
For the time to be so specific, that have to have you turning in everything on time every single time, no late fees. So it's kind of giving you a bit of a grace period. Well, not a grace period. They're assuming you're not going to be perfect with it. Or not.
It's actually a little bit more simple than that. I like your thought on that though. So listen to this, guys. And when you apply a loan, look at me. When you apply for a loan, whether it's a boat, a car, even a house, it doesn't matter. But let's stick with a car or a boat. Specifically the car loan. The typically people either get a 4-year loan, a 5-year. You guys are not looking. 5-year, 6-year loan, up to a 7-year loan for a car. And for boats, a little bit longer because they typically are a lot more expensive. You can get up to a 15-year loan for a boat, believe it or not. But they're whole numbers. You can't get a 4.5-year loan at a bank. They don't exist. Either the number of years for your loan, whether it's a car, a boat, or a home, has to be a whole number. So believe it or not, it's actually that simple. They don't have loans for 4.97 years. It does not exist at a bank. They don't give those kind of loans. Does that make sense? Okay. So terms have to be whole numbers. Write that down somewhere in your notes. Terms have to be whole numbers. And in this case, if she doesn't want to pay more than $250 per month, she has to round up versus down, because if she rounds down, then the monthly payment will be higher than $250. It'll be between $250 and $300. And that's not good for her because she's trying to stay within budget, because everybody typically has a budget. At least I do. Okay. All right. Okay. So there you go. That's number 3. Now let's handle one more before we leave, and then I'll do the rest on the second page tomorrow. So let's go and let's transition to 7 through 10 because that's fairly short. Okay, and this is an example dealing with what's called a yearly payment schedule. Okay, this shows a couple things. Okay, it's a yearly payment schedule shows what the principal paid is per year. That's all these numbers here over the year. And the other thing it shows is what goes to the bank, what you pay the bank, which is called the interest, because the loan is not free, you guys. Okay, you have to pay the bank to access money or to borrow money. And that payment to the bank is called interest or a finance charge. It's the same thing. So it shows two things. So for example, in year 2016, this is where we start. In this case right here, in this year, 2016, $3,702.31 was paid off the loan. By the way, what's the loan? Look at the chart here. How much, what was the loan? What was the original loan amount in this table? What do you guys see?
76,000.
That's right. So it's right up here. This is your loan amount. AMT is amount. So the loan amount is 76,000. Now, out of this 76,000 in the first year, $3,702.31 was paid, goes towards this balance. So it's 76,000 minus that number. All right. This portion here, the interest paid, I'm looking here, guys, in the first year here, you had to pay the bank $3,158.45 to borrow this money, which is a lot of money. But if you look closely here, as you go from year 2016 all the way down here at the end, which is the end year at 2030, your principal increases over time. So let's put down INC for increases. It goes up, which means the amount that you put towards the loan goes up over time, which is how you pay off your loan, by the way. And then the interest paid decreases over time. In the first year, you pay $3,100 roughly. In the second year, you pay $29, almost $3,000 actually. In the third year, in 2018, you pay $2,830. So it decreases over time. So over time, you pay the bank less and you pay off the loan more. Do you see that in the table? Who sees that? Who's understanding what I'm saying up here? Some of you guys are giving me feedback and some of you guys aren't. You guys, this is where the Q&A happens. If you don't see it, then you got to ask questions. The important thing is that you understand. So you can read these things and understand what it means over time, okay? Or on your own, excuse me. Okay, let's do another one here. What's the length of the loan? What is that? You start in 2016 and you go to 2030. So how many years? Number of years? You guys tell me. What's the length of the loan?
15.
You guys agree or disagree with that? Two people said. So just out of curiosity, Mia and Maddie, you guys said 14. How'd you get that? Can you tell me?
I did 2030 minus 2016.
Thank you. Okay, so let's write that down, okay? So let's go to the margin here. 2030 minus 2016. So end minus initial, which is equal to 14. I agree with that. However, look at the payments, or look at the table. Count, everybody physically count the years. 1, 2, 3, 4, 5, 6, 7, 8. Everybody count. Everybody do that real quick. How many years are there listed in the table? No, Riley, go ahead and look at the next column, the year column. There's 2 year columns. So go from 2016 all the way and use the next column too, all the way to 2030, excuse me. Okay, so you guys are, no, it's okay. It's okay. So Let me just point this out. This is a very common mistake that people just take the end year minus initial year, which is 14. But you're always, when that technique, you're always going to be one off. So what I do is, since I know that now, as I always do that, I always subtract like you guys did in the beginning, Maddie and Mia, but I always add one back. So go +1 and then equals 15 years total. So the fastest way to get the number of years is by subtracting, which Maddie and Mia did, which is totally the right thing to do, but always add one back because there's always one more than what you think. Maddie and Mia, does that make sense? Or everybody, does that make sense? Because the actual answer is 15 if you just count them up. It always happens. So subtract and add one, it works every time. Okay, so let's put down 15 years here. What's the monthly payment? So how do you figure that out? So let's let's take a look at let's focus in on year 2016. So let's go up here. Let's go up here. Everybody look at year 2016. Don't mean to cover that up. So there we go. So everybody calculate the total paid in 2016. Figure that out. Total paid. Can you guys help me out with that? You paid $3,702.31 in principal. You paid $3,158.48 in interest. But what was the total paid during that year? Can you guys help me with that, please? You can use Desmos, just type it in. Focus it on years 2013. You gotta add the principal plus the interest to get the total paid. Because you paid $3,700 to the loan, but you also paid $3,158 to the bank. Do you guys agree with Mia's number there? Okay, I just want to make sure you guys are in agreement. Okay, so let me write this out. So 370231. This is in reference to 2016 plus 3158.45 is equal to, you guys said 6860 and 76 cents. I happen to agree with that. Okay, so this is for the entire year. For the year. So for the year. But they're not asking for that. They said, what is the monthly payment? And in payments, they're always the same every month. They don't change. They don't go up and down. Hint, hint, hint. They're the same. A house payment is always the same over the 30-year loan. A car payment is always the same over the life of the loan. A boat payment is always the same over the life of the loan. So what is the monthly payment for during that year? What do we do? Mia, how'd you get that?
I took 6,860.76 and divided that by 12.
Yeah, and Riley agrees with you, and I'm sure others do too. So the monthly payment, as you just said, is 6,860. All right, divide that by 12, and you get 571.73. So 571.73, because there's 12 months per year. Everybody knows that. Okay, and the only thing that we need to do is to get the total interest. So how do you calculate that? Just tell me how. I'm not asking what the number is. So can you guys just describe how you would get it? That's all I'm concerned with right now. Look in the table, it's all in green. How do you get the total interest paid over the life of the loan? What's the simple thing that you guys need to do? Well, you could do it that way, Riley. Be more specific, Mia. No, don't. No, you could do it that's actually correct, Riley. So cool. Okay, so which ones do we want to add up? Be more specific. Jonathan, don't put that out to the class. So Jonathan, that was a good idea. I just wanted you to put that out to the class. So you add up all the interest payments, and they're in green, you guys. Okay, so you add up these guys and these guys. You sum, or you can say add, okay, all the interest payments, okay, which is in green. Okay, and you can do that on your own. That you can do a couple different ways. All right, so that's your first little glimpse of what's called a yearly payment schedule over the life of the loan. And when you do buy a car or a boat or a house, you guys are going to experience these things. It's part of growing up, and that will happen. You know, probably. Well, you probably buy a car sometime during college, and you probably buy a boat or a house. You know, obviously out of college when you get a career going. No, Jonathan, you're all good, buddy. Thanks for participating. And Riley too. I'm glad you guys are participating. That's what I care about. And I don't care about if you ever make mistakes or you have different thoughts. The fact that you guys are participating is the important thing. Okay. All right. We're going to stop here. Now, here's what I want you guys to do before Thursday. So let's go back up to the top and circle the following ones. I want you to do number 1 on your own. Okay. You can do this starting tonight. Okay, so just circle the following ones: 1, 5, 6. Okay, just circle the following problems here. You guys do the rest. And number 11. Okay, so, and then on Thursday, this is Thursday, TH is Thursday, and then 13 on is Thursday. And then I will finish up with you on Thursday, and then we will submit on Thursday as well. So you don't have to submit anything tonight. The only thing I want you to do is do, like I said, 1, 5, 6, and 11. And then if you want to try number 12 and so on, if you know how to do linear regression, and well, you know how to do that, but I don't know if you know how to do quadratic and cubic regression. So we're going to do all that on Thursday. So just finish up a little bit. You don't have to submit today. We'll finish up on Thursday. You submit on Thursday and we'll be good to go. Give me a thumbs up if you understand what you guys need to do. Just a little bit more, okay? Just make sure I was clear. All right, very good. Good participation today. I'm proud of you guys. Good work. Make sure you also do your quiz corrections and get those in. Get the grade bump, okay? And then I'll see you on Thursday. You guys have a great day. Leave me with a smile here, okay? And you guys have a good day. It was fun working with you guys. And if you need anything, you could stick around. If you need intervention, let me know. I'll be around here too today. If you guys need to come at 1:10, I'm available. You can request a meeting with me at any time. Just message me through a remind and let me know that you want to come on in, and then I will be available for you guys. Okay, so you guys have a good one. See you guys. You're welcome. Okay, does anybody have any needs right now I can help you out with?
I'm just trying to figure out number 10, and I'm just staying right now to see if I need to ask you a question real quick. Is that sorry?
Sure. Okay, go ahead and continue. Let me know.
Thank you.
Do you have the answers handy to check your work?
No, but I can pull them up.
Okay, at least you know where they are. Okay. Matthew, what do you need, bud?
Mine's not like school related. It's more of like outside life related. So like anyone who needs like school stuff can have that like answered first.
Okay. Xavier, what do you need, bud? I was afraid of that. Okay, Michael, your turn.
I was wondering when you estimated the video would be posted of the class.
Usually every time we end our sessions, it takes about 20 to 30 minutes for Zoom to produce it and send me the links. So, you know, we end at 12:30. So maybe between 1 and 1:30 is usually when I put it up, or when I
Where
can,
can I?
because, you know, it takes
Is
time
it,
to produce.
sorry.
Okay, go ahead.
Where can I access it?
It's
Is it
always
gonna be in
in where you submit your work. So let's go to Canvas.
the homework or
Yeah,
or
it's
like the
where,
workbook? I mean.
yeah. So
Oh,
we're working on 3.4, right? So let's go
yeah.
back to 3.3 for a second. Okay, I'm gonna open up 3.3. Okay, so it looks like I haven't put it in there. Okay, so I have to do that. So 3.3, let's go back to 3.2. I just want to make sure. I usually put all my videos that I produce. Oh, there you go. So I just haven't put the last session in. Forgot to do that. It's always where you submit your work. So if you need help on 3.2, then you go to 3.2 workbook. Today, what I'm going to do when it's ready, I'm going to open up 3.4, and I'll do the same thing for 3.3 as well. I'll put the videos in through here, and there'll be 2 videos, because one for today, Tuesday, and then when we finish it, I'll put the second video in so you guys can access it. It's always where you submit your work, Michael.
Okay. All right. I'm gonna write that down. I think that's all I have to ask.
Okay. Well, like I said, you can always message me through Remind. If you need more help during the intervention, let me know. And then you and I can Zoom later on in the day. You know, interventions from 1:10 to 2:30.
Okay.
Okay? Just talk to me. Communicate with me later on, and I'll help you out.
All right. All right. Thank you.
You're welcome. Have a good day. Riley,
You too.
thank you.
So for number 10, and I feel like I'm doing this wrong. So what I did was, you said the total amount paid for each year didn't change, right?
Yeah, it should be the same over the life of the loan, but let me just check this on the schedule here. So let me do a quick calculation here. It
Okay.
should be the same, but let me verify something here. Let me bring up Desmos. I just want to be absolutely sure. So what I'm going to do, Riley, is we're going to gotta get my calculator going here. Oh, I know. Okay, hang on. I changed. There we go. Okay, let me check year 2030 and compare it with 2016. So I'm going to add up. I'm looking at 2030 right now. So I'm going to take $6,700, $5.73, and I'm going to add it to the interest for that year, which is $157.40. That's weird. You know, it's not
7.6 on your thing.
yeah, that's for 2016, and it's not the same. So in this payment schedule, the total paid per year does not remain the same over time. So what I would do on this question here, I wouldn't use the total paid minus the two interest. Minus the principal. I would simply just add up the columns in green, the interest paid.
Okay, thank you.
Yeah, so, or, yeah, I wouldn't do that. I would simply just add up the interest column. So when I did that, Riley, I went to this one here. I went to the other calculator, just so you know. And when it comes to adding up a bunch of numbers like this, I like this technique better. So let me just show you while you're here. I put it in a form of a table, and this is something we've done before. And I put all these numbers in green, the interest payments over the 15 years, and I put them in a table, and then I total up using the functions. Do you remember doing that with me in a chapter? I don't know, the previous chapters?
Yeah.
Do you know what I'm talking about?
Yeah.
Okay. In fact, you know what? I might be able to bring it up. Hang on, let me see. Oh, it's right here. This is how I did it right here. So I entered all these numbers in, and then I just totaled them up using the functions in Desmos, and I got a total. And I used my 9 keypad because it's easier for me to enter all the numbers in versus the digital one. And I just bust out all the numbers, go to the next one, type in total of X1, and it generates it for me. Instead of using this right here where you have to enter all the numbers in, and it's kind of hard to see 10 numbers in the string. So I like the table method when I add up like 15 numbers, especially 6-digit numbers. I like making a table and then using the total function personally, but it's totally up to you on how you want to do it. Okay.
Thank you, Mr. Ainsworth.
You're welcome. You too. Have a good day. Good job today.
Thanks.
Okay, Matthew, your turn. Go ahead and speak away, buddy.
Okay, so I was gonna tell you that. Okay, so one of my like mom's friends, her daughter needs like help in math for like tutoring because like she hasn't been getting like good grades because like the Zoom stuff going on, and yeah, so she asked me to help, and I said I'd like tutor her. So they're like still figuring that out, but this is gonna be like technically like my first like part-time job kind of thing.
You know what? I'm glad you brought this up because believe it or not, the person you're looking at, that's me.
Yeah.
Started tutoring in 1984 when I was a junior. So, and I started becoming a tutor when I was really young too. And it happened, I actually remember this. I was in, it was called math analysis, but it was the same as pre-calc or whatever. And my teacher said, hey guys, if anybody's, doing really well in here, like I'm talking to all my A students here, if you guys want a tutoring job, I know people who need tutors, and they, at that time, this is 1984, they were paying $5 an hour.
Yeah.
so, we're talking a long time ago, right? We're talking 45 years ago. So in 1984, I had my first job as a tutor, tutoring math, and I didn't have a car as a junior. So, but I had a bike. So I had the bike from house to house, and I go to their house in the evening. I tutor their children as a junior in high school, and I made $5 cash an hour. And I forgot what minimum wage was back in 1984, but that's why I started. And then I continued that as a senior, and my pay increased. And I was probably making $10 an hour by the time I was a senior. And then when I went to school at Cal Poly, I continued it. I was already pretty good at math. I went to school as an architect, believe it or not, first.
Oh, I didn't know.
Yeah, I didn't start in architecture. I was gonna become an architect. So I went to Cal Poly Pomona as an architect, but during that time, I kept my tutoring job out. So I had a car by that time. So I was driving house to house, and my pay went from 5 to 10, and in college it was 20 an hour. Now in 1986 at that time, that's pretty good money.
That's like $30, right? Like around like today's money. I'd be like around like 30 somewhere.
Yeah, because it's cash under the table, so it's not taxed. And
yeah, exactly.
And $20 back then is a lot more now, right? So
yeah.
And then I continued, and as I got more and more experienced, I started working at the college in their math lab, the tutoring lab, and I got paid for that through the college, but I made more money on my own. So getting educated in the mathematics and in the technical classes is really good because you can make a lot of money in college. A lot of money, it depends on how you work it, but make really good side money just by getting knowledgeable in a subject like math. whatever.
Yeah, exactly. Like my college plan is I'm going into like, computer sciences and like data analytics. So like having to look through like a bunch of like numbers and stuff like that and like make just a bunch of like really like complex like formulas. That's what I'm going to do in college and study.
Yeah, but guess who your client base is going to be?
It's going to be like the high schoolers and like college and fellow college students as well.
Guess what? Guess what subjects in college are going to be your clients?
A lot.
No, which part of college? What other majors can?
Oh, business. Yeah, like business majors that will need help and stuff like that.
Yeah, business. They have to take business calculus, and so
Yeah.
people that go into business don't necessarily want to go into mathematics. So typically they stop at the pre-calc level, but then when they get to college, they have to take a class called business calc, and it's different than the regular calculus, but it's still rigorous. And so I had a lot of clients that were in college taking business calc, and I was teaching them business calculus as I went through. And then of course I taught there were a lot of people going to become a teacher or like liberal arts, and they were the elementary school teachers and they need help with math. So there was a lot of clients with that one. There were a lot of clients. So I made a pretty good living and I kept on going, and I've been tutoring since then. I tutor on the side here, but now I'm making 60 an hour now. That's what,
60 an hour. Oh, nice job.
Well, that's actually, and that's on the low end. If you go to the tutoring agencies like Mathnasium or
that one's like right next to me. Yeah.
Guess what they charge per hour?
How much?
Probably around 80. And then you got test fees, all these other extra fees, and so people spend anywhere from $300 to $500 a month putting their kid through Mathnasium every month.
That's actually good for me because I was doing the math and I thought I was being on the high end with $25 an hour. But with those prices that so I was just doing like some calculations and I was like planning on charging like $25 an hour because like if the competition is charging $80 an hour, they're going to want to go to me because I'm charging $25 an hour.
Yeah, you just got to have the knowledge and the experience, which you don't have because you just started.
Yeah, exactly. So that's why.
And it also depends on who you're tutoring. So if you're tutoring a 5th grader versus an 8th grader versus a senior, your rate's going to change.
Yeah, because of the complexity of it.
And then also this is new for you. So
yeah,
you got to start off at 20, 25. You might be able to get 25. And if you're not getting too many bites, I would drop it down to 20 and start at 20. Mm-hmm. 20 is a typical rate that college students get when they're in college. 20 is typical. And so I'm talking from the parent point of view. So when a parent doesn't want to pay full price for me as a teacher, and which is because I'm at 60 an hour because they just flat out can't afford it, because sometimes that's the case, right?
Yeah.
Then they pay for a college person at 20 because they can afford 20 versus 60. Mm-hmm. But if it's a more advanced subject like calculus, for example, then they're going to hire guys like me, because I have the background.
Yeah, I'm thinking more of like maybe like 10th grade down. That's kind of what I'm thinking.
Right. And so when you advertise, make sure you advertise for that. So I would put subjects. Like when I advertise, I say anything all the way up to calculus, nothing beyond calculus, because I haven't done that stuff in a long time. So I'm talking about the stuff that comes after calculus. So when you put your flyer out, either on Craigslist or you have your little business cards, like I have business cards and flyers and all that, you have to put your name, all your information, and then your subjects that you tutor on your business cards. And you can go online and get a set of business cards for like 500 business cards for like $20.
Yeah, my stepdad, he has like a lot of business card stuff, so I'm gonna ask him for that as well, so I can make it more of like a legit kind of like business. You know what I mean?
Yeah, and just go online and type in business cards for tutoring, and they'll comes up with all kinds of images. Get some ideas from that. Make it simple, specific. List your subjects, name and email, and you're gonna have to put your phone number on there because you're gonna have to hand it out to a parent.
Yeah.
because you're going to be talking to the parents.
Yeah, exactly. Yeah. Yeah, and I've been like trying to like convince like my parents to like, I don't know, get like a part-time job, because my mom is like, my dad is like, it's like the complete opposite, because my parents are divorced, so I don't live with my dad. So my dad like really wants me to get like a part-time job at like Subway or something like that. And for me, I just like don't see myself working in fast food, not to like rag on them, but that's just something that's way harder for me to do, like as like my personal skills, than like to tutor someone. So like I'm thinking this would be like a really good like part-time job.
Oh, really?
And yeah, like also like it's good for me because I'm reviewing like some math concepts as well and stuff like that, and like teaching people. So it gets me better.
Exactly. So in respect to that, it keeps up all your skills. So like I haven't tutored calculus in a long time, nor have I taught it in a long time. I used to teach it at Great Oak for years. And I used to teach have you heard of the pre-calc class, the accelerated pre-calculus?
Yeah,
class?
I did. I heard that.
I used to teach that for years, but I haven't done it in, I don't know, it's been like 5 or 7 years. And so if I was going to tutor that or teach that, I would have to do some studying and reviewing, because, because whatever you don't teach or tutor for years, kind of, you get a little weak at it, so the tutoring keeps your skills up. So when I was teaching and tutoring, I could just whip this calculus out like no other, so keep it up, and then you're right, it will make you better. So, and you can make some good side money. So do that, and then let me know how it goes.
Okay, yeah, I'll let you know how it goes. I'm still like figuring things out and stuff. So yeah, thank you for like the help.
Yeah, we can chat anytime. So throughout the year, okay?
Okay, cool.
All right, well, Matthew, thanks for sharing. I appreciate it, buddy.
Yeah, thank you.
You're welcome. You have a good day, and I'll see you on Thursday.
Okay, you too.
What day is today?
Today's Tuesday.
Yeah,
so
see you on
Thursday.
Thursday.
Okay, bye.
All right, see you, bud.